Hello. In today's video, we're going to go over Chapter 20, the last lecture within Chapter 20. This pre-lecture video will go over, basically we're looking at our E cell and relating it back to our Gibbs free energy. And we're going to look at E cell either as a standard or using our Nernst equation to figure out our E cell for a non-standard conditions. We're going to look at batteries, how batteries work, and then how we can construct fuel cells. Then we're going to look at what's called we'll look at corrosion and cathodic protection, and then we're looking at electrolysis in electrolytic cells. Okay. So just some equations to know for this. So back in our last chapter we had delta G, in this chapter we have delta G is equal to negative N Fe, where N is our number of moles, F is Faraday's constant, and E is our cell potential. So this would be non-standard conditions, and then under standard conditions we'd have it look like this. So, and number of electrons. So the number of electrons in a redox process, F is Faraday's constant, which is 96,500 coulombs per mole of electrons, and then E is our cell potential. Okay, and then we can bring in from, so this is a new chapter 20 equation, and then an old chapter 19 equation is delta G is equal to delta G naught plus RT ln Q. So using these two equations and combining them, we get what's called the Nernst equation, which was E cell is equal to E naught cell minus 0.0592 volts divided by N log of Q if we are at 25 degrees Celsius. Okay, so our temperature 298 Kelvin. Okay. If we are not at, so this is what we call our Nernst equation. If we are not at 25 degrees Celsius, we would also just use E cell is equal to E naught cell minus RT NF ln Q. So not at 25 degrees Celsius, we use this one. Okay, so we'll look at more into using this equation, but if we're at 25 degrees Celsius, Nernst equation is this one, and this is one that we'll most commonly use. Okay, next, after we look at the Nernst equation, so after, so using these two ideas, solving for our Nernst equation, so solving for our E cell at non-standard conditions using our standard E cell, and then we can also look at a battery. So in this chapter we're going to look at batteries, and here we have 2 or more voltaic cells connected in series. Okay, and we can have batteries be primary cells or secondary cells. Where a primary is non-rechargeable, so your redox reaction can't be reversed. Secondary is rechargeable, so we can reverse the reaction. So in another lecture, we're going to actually look more at our different types of batteries, but the ones we're going to look at in detail are lead-acid batteries, these are the ones that you guys would see in a car. Lithium-ion batteries, so those are the most common rechargeable batteries. And then we'll also look at fuel cells. Which is a similar idea to a battery, but it's going to convert chemicals into water, producing electricity in the process. So we're basically taking H plus and O2 and producing water. So we will look more in detail on battery types and fuel cells. And we're going to talk about the idea of corrosion. So corrosion is oxidation. So rust is a form of corrosion. And a lot of times things are used in order to prevent rust from occurring, or from oxidation from occurring. So you can use what's called cathodic protection. And that is going to prevent oxidation. So this can be used in order to basically protect a material from being oxidized. So you're going to add in a metal that is going to be a anode. So add a metal that acts as an anode, so it will be oxidized, keeping the desired metal from being oxidized because it has now become a cathode. So the only thing that can occur to it is reduction, and you can't reduce a metal. Okay. Next thing we're going to be looking at in this final lecture of our class is electrolysis and electrolytic cells. So, electrolysis, non-spontaneous reaction, is driven by the addition of electrical energy. So unlike a electrochemical cell, where we produce electrical energy using a chemical reaction. Here we use electrical energy to cause a chemical reaction to occur. So the electrolytic cell is the opposite of a galvanic cell. So it's going to use electrical energy to produce or cause a non-spontaneous reaction to occur. But we still have our two electrodes, and we're still having the reaction occur similarly as we have in a galvanic cell. So you're going to add in energy, and from there you can determine how many moles of electrons you are producing, and using those moles of electrons you can determine how many moles of the substance is oxidized or reduced. So in electrolytic cells, you determine the quantity of charge, and you can determine the quantity of charge by the fact that 1 mole of electrons is equal to 96,500 coulombs. And you can basically take your coulombs and set that equal to your current in amps times by your time in seconds. Okay? So using your coulombs, determining your number of coulombs by taking your amps times by your time, you can convert it into moles of electrons. And from there, using your balanced equation, you can determine your moles of substance. So you're just going to do a stoichiometry problem. And then, using your formula weight, you can determine grams of substance. So you can figure out, using how much charge you have, how much substance you can oxidize or reduce in a given amount of time. And that's going to be the real calculation we're going to be doing with our electrolytic cells. With electrolytic cells, a lot of you guys might have heard of electroplating. That's an electrolytic cell to produce electroplating. So if you've ever had a ring that's had like rhodium plating or something like that, it's done using electrolysis. So they basically put that into they put your ring in a vat of molten salt, and they do an electrolysis process that causes that metal to plate on the ring, and it doesn't go on any gems or anything like that because they're not metal. So it causes that electroplating to occur, and you can determine how long you need to go based on your amperage. Okay, well, I'll go more in depth on all of that, but that is everything for chapter 20. So it's pretty easy, pretty quick, and I'll see you guys soon.